Hi Chem Peeps. We just finished a video on colligative properties and now we're going to apply that concept to this problem. In this problem, it is asking us what the freezing point of 1 kilogram of water is when we have 3 moles of sodium chloride added to it, and or when 3 moles of calcium chloride are added. Notice that they give us a K of F value, and that is a constant that comes from a table. So when we're trying to solve for colligative properties with freezing point, the formula is going to be the change in temperature for freezing, so that's what this means, is equal to I, which is the Van Hoff factor, that's the number of particles that we will find per mole of the solute, times K of F times M. Now, K of F is a constant, so let's just label this. This is the Van Hoff factor. This is the constant for, oops, I don't know why my pen gets like that. It just has a mind of its own. So this is a constant, which they give, but we can also look it up on a chart in our index or our chapter. And this is molality. Now, I did a video on molality. It's concentration, and molality does not change with temperature. It is temperature independent, and so that's why it's used in this formula. Of course, we're multiplying here, so I'll put dots. Okay, so let's go ahead and solve for the one where we use sodium chloride. The sodium chloride is going to break into 2 particles, sodium ions and chlorine ions, so the I factor is going to be a 2. For calcium chloride, it's going to break apart into calcium and 2 chlorines, and so the Van Hoff factor is going to be a 3. We need to calculate molality. So molality is equal, oh, here we go. I think it might be me, not the pen, that's having trouble. So molality is the moles of solute over the kilograms of solvent. So let's go ahead and calculate the molality. In both cases, we're doing 3 moles. So it doesn't matter whether we're calculating sodium chloride or calcium chloride. They're going to have the same molality. So molality is going to be 3 moles all over 1 kilogram. So molality in this case is 3m. Okay. So let's go ahead and do the sodium chloride problem. So the change in temperature is going to be the Van Hoff factor, which is 2 for sodium chloride, times the constant, which is 1.86 degrees Celsius per mole, times the molality, which is 3 moles. And in so this case, our change is going to be 11.16 degrees Celsius. So what's the new freezing point for water with sodium chloride in it? Well, it's going to be 0 degrees, its normal freezing point, minus 11.16 degrees Celsius. And so it's going to be negative 11.16 degrees Celsius. So let's calculate the calcium chloride. So if we look at calcium chloride, we're going to have the change in temperature is going to be a 3 for Van Hoff. Molality, or the constant, is still 1.86 degrees Celsius per mole, times 3 mole. And so when we calculate this, the change in temperature is going to be 16.74 degrees Celsius. So the new freezing point of this solution is going to be the normal 0 degrees Celsius minus 16.74 degrees Celsius, which is going to give us a new freezing point of negative 16.74 degrees Celsius. So then what is the freezing point? The answer is this answer and this answer right here for each of the solutions respectively. I hope that helps. There's more examples to come. Find me on TikTok and YouTube at Kim's Chem Chats, and I'll talk to you later.